Hey folks, so this is going to be a video in section 5.3. This is the first of several, so I'm taking this section and splitting it up into quite a few different sections, shorter videos hopefully. All right, so what we want to do here is we want to take a look at simply finding trig function values of an acute angle, looking at a triangle. In previous sections, the only thing that we've done is to look at trig functions on the coordinate axis where I have x's and y's. This is a little different. I don't have x's and y's anymore, so SOHCAHTOA is going to be quite useful on this. All right, so take a look at example 1. It says that we should find the sine, the cosine, and the tangent for both angles A and B in the figure. So the first thing we're going to do is we're going to focus on angle A. And if we focus on angle A, then let's use SOHCAHTOA with this. Remember from the last section, SOHCAHTOA's sine is going to be opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So for my sine value, if I'm focused on angle A, the opposite over the hypotenuse is going to be 36 over 85. And that cannot be reduced, but we always reduce our fractions if we're able to. For the cosine of angle A, this is going to be the adjacent over the hypotenuse. So the adjacent is going to be that 77 over the hypotenuse. And then for tangent, that's going to be the opposite divided by the adjacent. So that'll be your 36 divided by 77. Once I have those, now let's take a look. Instead of focusing on angle A, now we're going to focus on angle B. So for sine of angle B, our focus is different. So now this is going to be opposite over hypotenuse, which is going to be these two, my 77 over my 85. One interesting thing to notice is that now that I have that, the sine of angle B is the exact same thing as the cosine of angle A, which makes sense when you're looking at a picture, but just something there to pay attention to. The cosine of angle B is going to be the adjacent over the hypotenuse, so that'll be 36 over 85. And then the tangent of angle B will be the opposite over the adjacent, so 77 over 36. All right, so for the second part of this video, we want to talk about cofunctions. When we're working with cofunctions, first of all, let's just work through a couple of these, and then I'll explain what they are. But it's always going to come in pairs of trigonometric functions. All right, so let's look at the ratio A over C. And if I'm focused on angle A, which I've highlighted, A over C is going to be my opposite over my hypotenuse. Well, we know that that's the sine of angle A. Well, now let's switch our focus from angle A over to angle B. Still, though, I want to look at the ratio A over C. So A over C, when I'm focused on angle B, is going to be the cosine. It's the adjacent over the hypotenuse. So this is going to be the cosine of angle B. And that's actually what I had pointed out in the last, in example 1, just a moment ago. All right, now let's go back. And let's once again focus on angle A again. Only this time, the ratio that we're looking at is A over B. All right, so when I look at A over B, focused on angle A, this is going to be the opposite over the adjacent. Well, opposite over adjacent is going to be the tangent of angle A. Let's change your focus to angle B. Still looking at the ratio A over B. And now A over B is going to be the cotangent of angle B, the adjacent over the opposite. Okay, last set. Let's look at the ratio C over B. If I am, since I already have highlighted angle B, let's go ahead and do that one first. If I'm looking at C over B, according to what B is, angle B, and this is going to be the hypotenuse over the opposite, the hypotenuse over the opposite. Well, if you remember, this is the cosecant, hypotenuse over opposite. Let's switch our focus over to angle A. And if I'm focused on angle A, still that's C over B is going to be the hypotenuse over the adjacent. So that's going to be secant. All right, now one thing that I want to point out, and this is going to be in the next statement here, is that cofunction values And right now, what we understand about cofunctions is that they come in pairs. So they're going to be sines and cosines are cofunctions of each other. Tangents and cotangents are cofunctions of each other. Secants and cosecants are cofunctions of each other. But there's more. It says that cofunction values of complementary angles. Remember, complementary angles are angles that add up to 90 degrees. And so what we have here is that angle A and angle B are complementary angles. I know that because all three angles add up to 180 degrees in the triangle. I've already used up 90 degrees in the right angle, so that means A and B have to add up to be 90 degrees. So A and B are complements of each other. So let's back up. We have cofunction values, they come in pairs, of complementary angles. So things like the sine of angle A is the same thing as the cosine of the complement of angle A. So cofunction values of complementary angles are always going to be equal to each other. Well, how do I put that into practice then? So it says in example 2, write each function in terms of the cofunction. And so first of all, who is sine's cofunction? Well, we know cosine is, so I know it's going to be the cosine of something, and I need the cosine of the complement. So the cosine, how do I get the complement of 9 degrees? Well, I'm going to do 90 minus 9 degrees. So it's going to be cosine of 81. Well, when I go to letter B, who is the cofunction of cotangent? Well, that's going to be tangent. And so the tangent of the complement of 76, 90 minus 76, is going to be the tangent of 14 degrees. Last but not least, the cosecant of 45 degrees, who is the cofunction? The cofunction is going to be secant. The complement of 45 degrees is going to be 45 degrees. So the cosecant of 45 is going to equal the secant of 45 degrees.